Okay, after the break, we come to the Windows OS process memory part, some kind of revisiting of our Windows internal classes. And also, we will cover the topic, what we call the direct kernel object manipulation. So if you have no time to watch my Windows internal eProcess YouTube video in the past, better go back. And if otherwise, you I will try to show some limited demonstration on that part. We go back to the relationship between the image file, which is the P file with text section, data section, and heap and whatever that map to the physical memory by the virtual memory manager of the OS, by the assistant of MMU and TLB in the CPU. You still remember we still using Win32-bit Windows process, user process. Here you see these logical memory. I assuming the diagram is not drawn into proportion because that another kernel LAN or kernel mode 2 gig is not so big when compared with the another 2 gig in the user space. But that is only give you some kind of abstraction. You see that the stack is going from the higher address increasing to the lower address, and heap from the traditional way from the lower address to increase to high address. And part of the program code, that is the text section, is low right here, and the DLL is low inside the lower part of the kernel, which is in shared memory links of that, most of them. And that is two data structure we call the PEB, the process environmental block, and TDBs, the thread environmental block, have been exported from the kernel to the user mode when we are going to check with the eProcess structure to find this information. Why TEBE? Because the situation is that is multi-thread environment process within the same process. There are have more than one thread is running. So that is the basic idea we have discussed in the Windows eProcess structure. Now we visit some kind of Windows structure described in the class of Windows internal. Main part you need to understand the list, which is what we call the linked list. Linked list is some kind of abstract data structure that is highly used by the eProcess structure. We call it doubly linked list structure, that is pointing from one location. Once we find one of the pointer residing in the variable called PS active process head, and PS active processor will point to the location of the active list. In the active list, there is two pointer, which is pointing to one to the predecessor eProcess structure, another pointing to the following successor structure. Well, then these two pointers have different name. One is called front name, another is called back name. So I will not be covering the data structure on the array and record a lot. And tree is important, interesting part. We call the one of the structure called VAD, virtual address descriptor tree. We are not covering VAT even though in our class, but VAT is important for allow the volatility to find the DLL. So I let you to explore these VAT tree information from the internet by yourself so that you can have better understanding if you want to dig into more in-depth. But today we only cover the doubly linked list from the pointer, the PS active head to the process content. So go back to one of the demonstration, we can find out about the active process how to find active process. You still remember the process 00, and then we can find each process, and each process to have different meaning. And here you will see the eProcess internal, starting from the eProcess structure offset 0, and then this offset 0 is called the process control block PCB. Actual PCB is a structure called K-process. And the K-process still have the dispatcher header and the thread list head and the kernel time. And the thread list head is doubling linked list pointer to the front and the back link, which is pointed to the K thread. And the PS active hack, as I said, from the usually from the KDBG, can find the PS active hack, and PS active hack supposed to point to the system process, PID equal to 4, and that process with a certain level offset from the offset 0, and it will go to the eProcess structure, pointing to front link to the or back link to the another eProcess structure. And also that is after the active process lane, you will find the object table, which is a kind of handle table pointing to which pointer which kind of object that has been accessing by the particular eProcess structure. And also we discussed the PEB, which is some kind of data around one mental block of the process pointing to the user mode environment. And if we can using the space type command in the local kernel debugger, you will find out one very important element that we need to cover today is the active process link, which from here we can find another eProcess structure. Bear in mind right now from each Windows version of the Windows OS, the kernel eProcess structure, sometimes they may have some amendment. But in our Windows 10 environment, we always be able to find the eProcess structure measured from the offset 0 to the offset of B8. Remember this, because based on this, we can manipulate our process structure to find out where is the next process. So if you want to pick into process eProcess structure inside the kernel by using WinDebugger kernel debugging, then you can type in the procedural register called the current process and check the eProcess structure and list them based on active process link front name and recursively. So after that, you can see the content details of the just equal to the you go to the task manager or the by using the process explorer to see what kind of information. So if you want to understand more about the active process lane, so you can follow the command I show right here. Remember, as the offset of the 17 is not the 17C is not the process link. The process link should be B8. You need to remember this so that we can cover it again in our DKMO situation. So what is direct kernel object manipulation? I hope I can do a demonstration after this slide if I can successfully handle the online demo. So basically, most of the Windows system before Windows 8, that is a fixed location of one variable, global variable, in the physical memory is our virtual memory. That is called the KDBG, global kernel global variable. And based on KDBG, you can find out the another global variable called the PS active active process head. Based on PS active process head, it will point to the first part of the eProcess structure inside the kernel. That is called the, I think that PS active hack will point to the system. And then based on here, you can find the offset from B8 to find the fund name, and fund name pointing to another eProcess structure. Here, I personally think that the diagram that I take out from the public information will not show the true information because, for example, the backlink is not pointing back to the backlink, but pointing to the funding of the previous eProcess structure. So now I using this diagram to illustrate how the process being identified by enumeration of the PS active head, and then see if I can do a demonstration on the this command so that you can see the detail. I already show you the string and XSD in the first part of today's lecture, but I will go to Windows kernel debugger to see whether this information contains the same content about the PS active head pointing to the system process. Let me switch to our virtual machine. Okay, we have already kickstart the eProcess, the local kernel debugging. Right now, I try to find where's the global variable of the PS active head. Then I'm using one of the command called examine NT exclamation PS active head. I'm using start to show all of them. Okay, it doesn't work, so I need to type the reload. You can troubleshoot. I cannot find the simple server. I need to check whether my virtual machine are running in good. I shall pause my recording. Okay, I have already fixed my internet connection so that when I type reload, I can access my, make my Windows debugger to connect to the Microsoft simple server. Then I try to examine. X is examine the NT active start means whatever. So see whether I can find this information. Oh, I typed something wrong. PS active. So it shows me the address of PS active process head at the offset of X something, which is inside the kernel. I remember this. Then I try to display type DT NT exclamation mark eProcess structure. Actually, you don't need to type the NT exclamation mark in most of the case. Then I put in my address. How about make sure I save with OX, and then remember that is the pointer from the PSS have pointing to the active list of the first process. Then the active process list entry is on the offset of 0B8. So I want to move from the offset 0 to B8. Then if I want to find the eProcess structure of the offset 0 of this process, then I need to minus hexadecimal B8. Then I want to move from the display this content about one of the structure field called the image file name. I don't know what is the offset image file name, but I just try to type. I try to display this structure image file name. Okay, it seems something wrong that is not correct. Let me double check my content, and I will pause the video recording. Okay, I find the errors. Um, okay, right now I'm going to do a demonstration to find out the PS active hack. Then based on PS active process hack to find the um, PS active list, which is at the offset of B8 from the offset 0 of the first eProcess structure. So previously I'm using wrong information. Let me redo it right now. So I go to examine the NTPS active head. So I have this address. This address is the location of the content of the PS active head. I need to find that is what is contained inside this address. I should not using this address as the location of the active process list of the first process. So what is the content? How can I examine the content of this address? So I using the DD display data. So in this address, it contains a data with the pointer to the first eProcess structures active process list. So I should use this as DT eProcess structure with or without NT exclamation mark. But this is not the beginning of the eProcess structure. This is the location from the B8. So I need to move back to the top of this eProcess structure. Then I try to find the image file name. Bingo, that is pointing to the system of the first eProcess structure inside my virtual machine. Okay, go back to this slide. I already amend my slide. Try to using the DD to display the location of the PS active head process PS active process head, and find the content and moving the content with minor with BA with the offset of PS active list entry from to the beginning offset 0 of the eProcess structure. Then find the image file name. You will find the same result as I have been demonstrated. So we talked about the DKOM, direct kernel object manipulation. My assumption is how we list the eProcess structure or the running process of my Windows system. So basically, we call the API, and actually they perform a function by checking the PS active head, and based on PS active head to find the first eProcess structure, and then by checking the each eProcess structures active PS active link entry front link or back link to enumerating in order to find the list entry of these process. Our objective is to do the DKOM is to hide one process. How can we hide one process? I will not show the demo, but I will show the step right here. The concept is all the eProcess, how about we take a bypass, changing the pointer from one location to another location. So if that is the case, can we do it? The answer is yes. The first we go to PS the eProcess list in order to find the eProcess structure and find the link, and based on the link minus and from the front link and back link, and we can find the information. So if you type the command just like I displayed on my screen, you can see that I can find the first active process list of one of my eProcess structure that I capture in this section of the local kernel debugging, and I can find the pointer the location contain the pointer for the next entry. So I using the same thing, DD, to display one character that will find the pointer and find this pointer and find this location. And then we go back to check the image file name, and we can find, in my example, I start up the Notepad process, and then find the Notepad process, the next pointer pointing the must not notify icon, and then I find the WinDbg, the bag. So that is the way how I can find what is my current position. So I try to draw this DKOM exercise in a table. So and at the bottom, you can see how I perform the exercise. So you can redo the exercise at home. Of course, when you start the Notepad and you start the WinDbg, maybe you may not find the same as I displayed in the recording, because the reason is we have different, each section will have some different arrangement. So in my example, I try to using the bang process 00 to list out all the process in order to identify my Notepad eProcess structure. And they find the offset 0 of this Notepad process is a B0DF7040. So I put it inside here. Then I moving down to B8 in order to find the address of the front name, the address of the backlink, which contain the pointer of next eProcess structure at the B0DE8138, and that is A6FE28B8. So I can find this information and try to using DD to display the content and confirm that contain the value of this 8138 and 26B6. And when you are checking this and try to find the next process, if you hold on for too long, sometimes at the background of the Windows system, they are trying to update the doublet linked list because a new process come in or a background process dropped. So if you find something wrong, you need to redo it and find the pointer faster so that you can find the next process. But anyway, my situation right now, I display the result from my local kernel debugging section previously I captured. So based on the information, I tried to display the eProcess structure. You see I'm using all lowercase to save time, but basically because WinDbg doesn't care about whether you type in uppercase or lowercase. So I based on the address pointer moving back, that is the pointer to the next eProcess structure. So 8138 is put it right here, and moving back minus by minus B8 so that I can display the image file name and find that the image is called the must notify icon. So I have the must notify icon by checking this address, moving back -8, so I can find X0 is the beginning address of the next eProcess structure. And also, and then I can display also the image file name, the active, other than image file name, I can display active link list, backlist. So I display this part. The backlist is stationed at the address of the, with a pointer to the 27 backward is this item. So I can find pointing to what is the content, it pointing to the this pointer pointing to the front name address of the previous one. So that is the way how I find this process. So the same logic, how can I find this process? Because this front name is pointing to this front name address. So I got this, and then by this minus B8, I can find the offset 0 of the next process. And then I type the image file name and find that it's WinDebugger. The WinDebugger is the backward link of my notepad. And then based on this, I can find also the active process link of that link is pointing to 378D0 something, whatever. And also find the front link. The front link show here 70F8. 70F8 is pointing to where? Pointing to the notepad process. So I can find out all the details. Now what I have to do, if I need to do a DKMO exercise, I need to change the content of this, pointing to this. And then change this content, pointing not to here, but pointing this content, pointing to this one. So I can wholly hide the notepad process. So what can I do? Just change it to 38138, pointing to this, and this changing this to 8B6, pointing to here. Before that is 70F8, and this was not pointing to this, but pointing to this. So you're clear about everything, right? Okay, we stop for a while, and then let me do the volatility demonstration and also give you some background how the function of the volatility.